In this video, I'll teach you how to do Taylor and Maclaurin series. Taylor and Maclaurin series are very similar, the difference being that Taylor series is centered at x equals a, whereas Maclaurin series is centered at x equals 0. These are the notations for Taylor series. F of x equals the sum from 0 to infinity of the function at a over n factorial times x minus a to the n. Maclaurin series notation is the same except the function and the derivatives are both at 0. This shows that the notation can be told by degree. This is the third degree Taylor series, so that means that you're going to go all the way out until the third degree polynomial, which is x to the third. Taylor series is defined as a representation of a function as an infinite sum of terms that are calculated from the values of the function's derivatives at a single point. And what a Taylor series does is approximate a polynomial by adding up an infinite series of sums. What Taylor and Maclaurin series do is approximate polynomials by adding up an infinite sum of terms. And the farther you go out for a degree polynomial, the more accurate the approximation will be. So say this is the function that you're trying to approximate in the pink, and the purple is your approximation. The further you go out with this polynomial, say the 10th degree or the 12th degree, the more accurate this function will become. Next is the construction of the Taylor or Maclaurin polynomial. So the first step is to have a function that you want to approximate. And you're going to take that function, and in this case we're going to do the Maclaurin series. So you're going to take the function at 0, and the value is 1 for cosine of x. And then depending on what degree you want to go to, here we're going to go to the 5th degree, you're going to take the derivative that many times. So we start with cosine of x. The first derivative is minus sine of x. Second derivative is minus cosine of x. Third derivative, sine of x. Fourth derivative, cosine of x. Fifth derivative, minus sine of x. And once you have those, you're going to then plug in 0 for every derivative. And these will end up being the coefficients for every term in your polynomial. So we start with cosine of x at 0, and that's 1. Minus sine of x at 0 is 0. Minus cosine of x at 0, negative 1. Sine of x at 0 is 0. Cosine of x at 0, 1. Minus sine of x is 0. Is 0. Once you have all of these values, you're ready to finally set up your polynomial. The first one is just the expanded notation, and it has nothing to do with the actual function we're working with. So the first term is the function value at 0. And then you add on the second term, which is the first derivative of 0 times x. The third term is the second derivative of 0 times x squared over 2 or 2 factorial. The fourth term is the third derivative of 0 times x to the third over 3 factorial, or 3 times 2 times 1. And then here again is the regular notation for Maclaurin series. The second polynomial is putting these values in for the regular notation. So the function value at 0 is 1, and the coefficient for the first degree is 0. So you're going to have 0x, and that term is going to disappear. And negative 1 is the coefficient for a second degree. So you're going to have minus x squared over 2 plus 0 x to the third over 3 factorial plus 1 x to the fourth over 4 factorial plus 0 x to the fifth over 5 factorial. And here is the notation for cosine of x. It's going to be a sum from n equals 0 to infinity of minus 1 to the n, and that is because it is an alternating function. and x to the 2n over 2n factorial is the sum. And this last one is getting rid of these zero terms. So you'll be left with 1 minus x squared over 2 plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus x to the 8th over 8 factorial. And notice I put on these extra terms without actually doing the derivatives for those, and that's because once you have this laid out for you, you don't need to do this anymore and you can just go off of this. So this example that we did with cosine of x was Maclaurin series because it was centered around 0. However, if we did another example that was centered around any other point, or x equals a, we need to accommodate that point. So for 1 over x, the normal series just centered around x equals 0 would be 1 minus x plus x squared minus x to the 3rd plus x to the 4th, and so on. But we need to accommodate for the a equals 2. So on every term of x, we need to do x minus 2. Or say if this was a negative, say negative 2 would be x plus 2. So you can do that in every term, and then you're going to adjust the notation as well. So you're going to have minus 1 to the n, which is the same for Maclaurin or Taylor. And you're going to have x minus 2 to the n, where if it was Maclaurin series, it just would have been x to the n. Now here are some other examples of commonly used Taylor series. Here we have 1 minus x, and this is 1 plus x squared plus x to the 3rd plus x to the 4th, and so on. And this is, might look familiar, the geometric series, and its notation is x to the n. E to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial, and the notation is x to the n over n factorial. Sine of x is kind of the opposite of what cosine of x was. You have x minus x to the 3rd over 3 factorial plus x to the 5th over 5 factorial minus x to the 7 over 7 factorial plus x to the 9th over 9 factorial. The notation is minus 1 to the n, meaning it's alternating, x to the 2n plus 1 over 2n plus 1 factorial, and this actually can also be written as x to the 2n minus 1 over 2n minus 1 factorial. So just keep in mind that these can be done either if you have memorized the notation or if you go through and do the longer way, which is all the derivatives. The last function I put down here for an example is ln of 1 plus x. So you're going to have x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4 plus x to the 5th over 5. And the notation is a sum from n equals 0 to infinity of minus 1 to the n plus 1, as you know, it means it's alternating, x to the n over n. So let's just quickly review what we learned. Taylor and Maclaurin series, very similar. They approximate polynomials. Taylor series centered around x equals a, Maclaurin series centered around x equals 0. Remember the notations, very similar. Remember that you could be told in problems to go to the 3rd, 4th, 5th degree, and that just means x to the 3rd, x to the 4th, x to the 5th. Remember that it's a representation of a function as an infinite sum of terms that are calculated from the values of the function's derivatives at a single point. So remember that you need to be doing derivatives for however many degrees that you're going to go out to, however many terms. Remember that you're going to be plugging in the point that it's centered around into both the function and the derivatives. And remember that when you set up the polynomials, you're going to start with the function value at 0, and then you're going to go on with the derivative values at your point. And remember that when you're also writing the polynomial, that you're going to go out ... plus, and then you're going to put the standard notation for whatever function you are doing. And then remember that Taylor series centered around x equals a, and you need to definitely make sure that you accommodate for the point that you're at by subtracting it from x. These are commonly memorized because you can use these, which are pretty basic, to manipulate to find other functions, which is a lot easier than going through and doing the derivatives. Thank you for watching. I hope this helped.